Hi guys, in this video I'm going to show you how to find the scalar and vector projection of a vector onto another vector. So first we are going to look at the scalar projection, which is just a number, and the notation for it is component, and then you write down which vector, so component of u, and then onto which vector you are projecting, that vector should be here as a subscript. So this is very important because if you switch them, it's not the same. So this is the u is the vector we are projecting on something else, right? And then v, vector onto which we are projecting. Okay, so let me first show you the formula. The formula looks like this. First, in the numerator, you're just going to have the dot product of the two vectors. In the denominator, you're going to have the magnitude of the vector onto which you are projecting. So if you are projecting on V here, then the magnitude of V should be on the bottom. If you were projecting on U, then magnitude of U would be on the bottom. Okay, so let's compute that. So first of all, let's compute the dot product. Now, before I compute anything, I always convert the vectors to component notation. I don't like the notation with the k's and stuff. By the way, the two should be outside over here. Yeah, I don't like it because it gets very confusing. So I'm just gonna rewrite it using components. So for ith component, that's just 1. There is no jth component, so that's 0. And then for kth component is -2. So never try to do any operations on vectors whenever they have ijk's in them. Convert them to components first so that you don't mess up. And then v, especially since some of them could be 0. So like, for example, in v, I can see that there is no ith component. So I'm going to put 0 and then 3 for the jth component and 1 for the kth component. Okay, so for the numerator, I'm going to have the dot product. So remember, the dot product is a number, and you just multiplying the corresponding components and adding up the results. And this is what I am doing right now. And the answer will just be -2. So -2 will go in the numerator. And then the magnitude of vector v will go on the denominator. So that would be square root of what? Well, let's compute the magnitude separately over here. So the magnitude is the square root of the first component squared plus the second component squared plus the last component squared if you have a third dimension. So this will just be 9 plus 1, which is 10. So this is square root of 10. So always simplify your answer. So here you could just put square root of 10 right there. Okay, so that's the scalar component. So we found that. Now, the vector projection, that is going to be a vector. So this is projection of u on v. And this is, again, very important to understand that that's going to be a vector. So what you do is you take the component you just found, which is a number, and then multiply that by vector onto which you are projecting. So we're projecting on v here. So I'm going to multiply by v, but not really by v with the hat. So the multiplication is just multiplication of a number times a vector. So this right here is just a number. So this is not like it's a dot product or a cross product or whatever. This is just a number, so like a scalar multiplied. So we're basically multiplying each component of v with the hat by that the number we just got, the scalar projection. So we got go -2 over square root of 10. Now, what is v with the hat? So we already know the magnitude of v is square root of 10, and so we just dividing each component of v by square root of 10. So this will be 0 divided by square root of 10, which is just 0. And then it'll be 3 divided by square root of 10. And then finally, you're going to have the last component, which is 1. And then divided that by square root of 10. Now we just have to distribute this constant to all of these components. Note that the vector projection will not have square roots anymore. And this is important because square root of 10 multiplied by square root of 10 is just going to go away and you'll get 3. So of course 0 times anything is just 0. This will be negative 2 multiplied by 3, which is negative 6, and you're dividing that by 10, not by square root of 10, because square root gives you the number. And then the last one will be negative 2 over 10. Now, if they require you to, you can reduce it. Like if they say enter the answer as reduced fraction, that can never hurt. But if they don't, you could just keep the answer as I had before.